Hello and welcome to this new edition of the Foojay Podcast. Today we are wondering what the future of source control and build automation will bring us.
Welcome to the Foojay Podcast, all your news about OpenJDK.
As developers, we like to automate the boring parts of our job. The source control system, build pipelines, and code analysis tools we use are crucial parts of this automation. And like almost everything in the software world, these parts are constantly evolving. We've switched from CVS to Subversion, and from Subversion to Git, and we started to embrace trunk-based development instead of creating branches for every feature that we work on. So, is this the endpoint? Did we find the holy grail in version control already? And what additional evolutions are perhaps still waiting for us? Let's find out together with these amazing guests.
Hello, I'm Trisha. I am a lead, what's my title now? Lead developer evangelist at Gradle. I joined Gradle in January. Before that, I was working at JetBrains doing IntelliJ IDEA advocacy. And last year, I had a tiny break to write 2 books, because that's what you do when you want to take a break. So the thing, the kind of thread that kind of follows all of my work, especially in developer advocacy, has been sort of developer productivity. How can we use our tools to be more effective as developers? How can we automate away the kind of boring stuff? Which is why it's really interesting to talk about version control and CI/CD and things like that.
Hi, I'm Ixchel Ruiz. I'm a developer advocate at JFrog. This is my first time being a developer advocate. I have been a consultant for the last 20 years. So before I was all about developing software, and now it's about sharing, learning, and finding new ways of bringing different paradigms into developers, and also bringing back the feedback from developers to the different companies, because that's also really, really important for us. And I'm super excited to be here. So thank you very much, everybody, for having me.
Hello, my name is Pierre-Étienne Meunier, and I guess I was invited here because I'm the author, one of the main authors of Pijul, which is a version control system, sort of a hipster version control system based on new ideas from mathematics. It started as an improvement on darks, which was itself also based on somewhat fuzzy theory of patches, and we've expanded it to make it super fast and easy to use, scalable. So before that, I'm working on this now, but before that, I was an academic researcher on a variety of topics, mostly related to asynchronous computing models. Before COVID-19, I was working on molecular computing, so how to build molecules out of DNA, how to program matter to assemble itself. And after, since COVID, now I'm working mostly in the energy sector, trying to help people share renewable energy with their neighbors. This is also an interesting theoretical problem, because you have a shared resource and you want people to get enough of, to feel that they got enough, and at the same time to optimize profitability of the setup. And I'm also working on people in parallel with that. So lots of things in parallel.
Thank you. And I am Hanno Embregts. I'll be your podcast host for today. I am an IT consultant at Info Support in the Netherlands. And when you're in consulting like me, you tend to get a lot of opportunities to work on different build automation setups and version control systems, which is one of the reasons why I developed a special interest in both topics. So thank you for being here today. Lots of interesting angles I think we can take. I think the one thing we can agree on here is that as developers, we like to spend most of our time on actually writing code and delivering values to our customers, right? So that means the more we automate our CI/CD process, the better it is, right? Or are there also any downsides in automating everything we do? Ixchel, I wanted to ask this question to you. What do you think about automating as much as we can of our CI/CD process?
Well, that works perfectly fine if we are thinking about the happy path, because then it's a matter of doing the repeatable things and that we know the inputs, we know the outputs, and we know the process. So actually, by adding the human factor there, we probably are adding more uncertainty, and we will be actually the part that is going to bring the errors. There are other tasks by their nature that they cannot be so easily to either establish or automate. For example, if we don't have enough knowledge or it's so rare, then the effort of trying to automatize this, it's higher than the return of our investment. And then are the tasks that are done to create new knowledge. Like we don't even know what the input is or the output. We're trying something completely new. So as you see, when we're talking about one side of the spectrum, the ones that input outputs are known and the process is well developed, we know what we want, then for sure, we should. It's our duty, because that is going to remove a lot of the uncertainty or problems that we have with technology. And most of their tasks are like that. But no, is everything feasible to be automated? No. Should we? No. I hope I kind of answered that question, Hanno.
Yeah, sure. Yes, sure you did. Because I fully agree with you. So Trisha, you told us that one of the fields that you're interested in is developer productivity. And Ixchel already mentioned the human factor, right? Well, developers are also humans, obviously. So could you tell us maybe something about that? How do you see the human factor working its way into developer productivity, or at least maybe having a detrimental effect to that?
At Gradle, we're talking a lot about developer productivity engineering, which
Right.
is about automating all the stuff that can be automated, basically removing toil. Some of the stuff that Ixchel was talking about in terms of the stuff that's repeatable, the stuff that's predictable, that lends itself well to automation. And so we're talking about DPE being the automation of the stuff that adds friction, increases toil, which means things like, obviously, automated tests, automated deployments where possible, being able to do things like the tool that we have allows us to speed up our build with both Gradle and Maven so that the build doesn't take so long, running the tests don't take so long, all these things that you end up waiting for as a developer. That allows the human to do more stuff which is good, that the human's good at, right? So if you're not waiting 20 minutes for a build time, for your build and tests to run, you are getting fast feedback from your tools, then you can be thinking about the next step. And what developers are really good at is being creative. So of course we type stuff into the computer, of course we tell the computer what to do, but the difficult bit is not that bit. The difficult bit is, how do I solve this business problem? Have I asked the right questions? Have I thought about all the angles? Have I thought about the way the user is definitely going to add the wrong thing and it's going to break? And machines can't do that. And although we're coming a long way in terms of being able to generate various tests which can throw rubbish at your application, you got like what's it called, like chaos monkey stuff and fuzz testing and all those things, you still need a human to kind of make the decisions about what should the application do, what does it look like when it goes wrong, when is it likely to go wrong. And so for me, developer productivity engineering, and which is aimed at improving developer productivity, is about automating stuff that should be automated. I talk about this when I talk about code reviews as well. Like code reviews, you should not be looking for formatting. You should not be looking for anything which a linter can do or anything which an automated test can do. A human is not good at that. So if you automate stuff that is automatable, then the human element comes in terms of, are we building the right thing? Are we building it correctly? Have we tested the right things? Have we covered all the areas that we wouldn't have thought of? Instead of spending, and I have been in jobs like this, instead of spending 3 hours running a manual process to release to the test environment every day, you get to spend those extra 3 hours writing good automated tests, or having conversations with the business about the problems you're trying to solve. And the thing that a developer should be really good at is being able to take these requirements, start working on things, but then go, oh, what if? And then being able to take those questions back to the business, because those are the sorts of things that maybe the users in the business haven't thought about. Oh yeah, it's true that we haven't really thought about this angle. Or you as a developer are thinking, well, we have a module which does this and you want a module which does this. What if the interactions worked like this? How would that impact the business or the user? And that's what we want to free the developer up to do. We want them to stop spending time on stuff which is like high friction, like low value, and allow them to start bringing the good human stuff to the process.
Yeah, we tend to produce still some good human stuff, right? There's the human factor, but there can also be benefits to that. Pierre-Étienne, do you recognize some of these challenges that a lot of time can get wasted waiting for builds or test results, and how do you typically tackle them?
Yes, yes, absolutely. So it's interesting to hear the industrial developer perspective, because I'm not an industrial developer myself. Like I don't work on huge projects with very large teams in a site, and sales people come at you and say, well, the customer wants that and this and so on. So yeah, I definitely recognize some of the challenges. So one thing that came to my mind as I was listening to Ixchel and Trisha was that sure, automation is important and good for you and good for everybody, but not just any automation. For example, one common pattern is that you have a problem that's completely artificial, that could be solved by just not having the problem in the first place. And you're like, okay, let's automate that. Let's automate the solution. For example, in development workflows, sometimes you're like, well, when you're using the wrong tools, like for example, back in the day where everybody was using SVN or CDS, some of the problems was locks on files, and so people were wondering how to automate this the way to take a lock on the file. And then we all have asynchronous distributed version control systems, and we're like, oh, this problem no longer exists. So many times, just being clever goes a long way before we actually need automation. So that's one different perspective I wanted to bring to the table. So many times, automation is good, sure, but sometimes just thinking deeply about the problem, modeling it really carefully and making sure that challenging it is important as well. For example, sometimes you have a model and that's the first thing that comes to your mind, and you're like, oh yeah, this model is really good. It took me a lot of effort to produce it, and you fail to challenge it. And you're like, oh yeah, let's go with that. And then you encounter lots of problems along the way that certainly you can tackle with automation, but also by thinking a bit more or challenging your models a bit more before starting out, you would probably not have even met problems. And another comment I had about something both of you said is that one of my use cases was French National Assembly. So the thing that made me realize that was the comment on the human factor and what should be and should not be automated. So the French National Assembly is, like any parliament in the world, is a typical example of version control. Bills that come to parliament are very rarely new laws, and we're completely out of the computer programmer realm here, right? So bills are very rarely new laws. Usually they're written as a patch to existing law. And they're really written in that form. If you look at bills, you're like, oh, replace words, replace every occurrence of words, foo by words, bar. And that's like all bills in all parliaments in the world, like most parliaments I've looked at least, are exactly formulated in almost the same language, or at least the natural language version of what we do with Unix diff. And so you have these highly qualified lawyers, and here comes the human factor, right? You have these highly qualified lawyers who take the amendments to the bill, so change patches to patches. So they take these amendments every week, and then they try to find the conflicts between the amendments. Then they present them to votes, right? So voting is like trend-based development. And then they manually apply them to, they resolve the conflicts by not presenting to votes amendments that would conflict with the currently voted amendments. So while they're in a session in Parliament, they have to manually keep track of what amendments were applied and how they were applied and what that changes for the next amendments and so on. That could completely be automated, not up to the last sentences where people have to actually know if what they've written makes sense, legally speaking, right? But a large part of it could be automated. And then after the vote, these people look at their law written in a Word document, and then they manually apply the amendments to the bill, and then the bill to the law. And so you have these highly qualified, highly paid lawyers paid to do certainly interesting, relevant legal work, but also manual version control. There's no CI/CD as well in Parliament, and we could have that. Imagine, for example, for the taxes, we have a budget every year. This is a perfect test case for taxes. How much are we going to get in tax money? How much are we going to spend? If I change the percentages on something in some law, what impact will it have? So all that kind of stuff. This could also be completely automated, and we're not doing that. But anyway, so that's not quite far from development. But this was just to say, well, sometimes the frontier between what can be automated and what cannot be is strange and interesting, and that's always an area of wonder, I think, in our job. It's like, how far can we go in automation? And can we solve the problem by just modeling it better? Or do we actually need to run big machines on huge test sets?
I think it goes without saying that a lot of stuff can be automated in general in the world. Just the fact that we are software engineers and we tend to have some experience with automation means that we are right there at the right place to automate it. But of course, if one of us has the ambition to transition into French law, we can maybe apply the automations there, help the French parliament into the future.
We're not using our parliament anyway these days, because the executive passes the bills without going through a vote. So that's a perfect test case for people like us, right?
Right. You mentioned some interesting things, Pierre-Étienne, and it made me think about using distributed version control right now. And I think most of us are using Git, but you can elaborate on that when I ask you the question later. The human factor is also a factor when you use a version control system, right? I have seen a lot of coworkers struggling with their Git repositories, and I was wondering, Ixchel, maybe what version control system do you actually prefer, and what have you seen out there in the wild when your coworkers used version control that they also kind of wasted some of their time because they ran into some problems there?
In terms of tools, what I have seen out there, actually, I started with Subversion at the beginning of my career. I actually had to deal with it. I have a brief encounter with Mercurial in some of my customers, but most of them, and since some years now, most of the people that I encounter, developers or companies that I collaborate with, it was mostly Git. Git is an improvement into what we had before. I mean, having complete code base repeated, different centralized ways of sharing the source code was a little bit complicated. And then, for example, having to resolve all the conflicts before making a commit, instead of Git, like committing your actual work and then trying to figure out the conflicts. It's also an improvement. How do you see your work, and how do you see yourself collaborating with source code, a large source code? The challenges are obvious. I mean, at least for me, it's our code base are increasing in size in such high speed pace that we need actually tools that are easy to use and can keep up with all these code bases, extremely large code bases, and with different kind of binaries or files. Git, it is very efficient for some things, but also allows people to get really frustrated, as you mentioned, Hanno. I have seen and I have people refer to Git and how do you get from point A to point B, and saying, well, you can get from point A to point B like a snowflake. Totally different ways to do it. And I have seen people that use the reflog like their best friends. And I see people that don't even understand what the reflog is. I see people going and driven crazy because of all the merge conflicts. And when they are seeing the merge conflict and says, okay, 3 commits solve 180 to come. And they are like, oh my God, what should I do? I have seen bad practices, rewriting history. I have seen so complicated workflows that you are like, what were we doing in the first place? Like, I mean, we've been working on trying to fix the state of the files, but at this point, I even forgot what we're trying to achieve here. Right now, I think Git is the most popular one. It's very useful. It's very powerful. I think it's the industry almost default. I think you still can misuse the tool. And I think there is still a lot of unknowns. There are still a lot of best practices out there. But I still think that the level of usage of Git in the normal developer is not proficient. So I still think that we have UI interfaces that obscure a lot of the main knowledge of Git. And as a developer, in my perspective and in my way of behaving, I like the command line. So that gives me a lot more of control. I know, Trisha, I know. But at the beginning, it was the best way to actually tame down that beast. Anyway, I think I hope I answered your question, Han.
Yeah, you did. Actually, this really rings a few familiar bells for me. So at Info Support, I teach a few courses, and one of them is Git for developers. It's one of the first courses that are the people that start out at our company do. And I always try to teach them to use the command line. But also, one of the first things I show them is a wonderful website that is called dangitgit.com. We can add it to the show notes. It's a very funny website created by Katie Seiler Miller. Dangitgit.com, and it's just a knowledge base of stuff you can do to fix up your repository when you did something wrong, because doing something wrong with Git is quite easy, but then fixing it, well, that is just a bit harder. And it's just a knowledge base for Katie to be able to refer to it back again when she encounters a similar issue. So I completely agree and recognize the things you said. Trisha, what are your experiences here? I mean, do you like the Git command line? I got the feeling from Ixchel that you don't really, but you can elaborate.
I mean, Git is my default as well. I mean, everyone uses Git these days. I actually agree with a lot of what Ixchel says. I don't mean this as a criticism of normal developers, of like the majority of developers. When I say many developers don't know how to use Git properly, it's not their fault. It's that the tool is so powerful, so huge, has so many different variations, is used differently by almost every team in the whole wide world. It is impossible to know the whole tool. It's impossible to know how to use it properly. One of the things, was slight plug for my own book. One of the things I tried to teach in the IntelliJ IDEA book I wrote last year, and this comes back down to the command line versus the UI. So IntelliJ IDEA has a really nice UI for working with version control. I'm not really a command line sort of person, so I do prefer using the UI. When I was trying to I indirectly teach version control while teaching it through the medium of IntelliJ IDEA. The idea is just to try and expose developers to the smallest amount of stuff they will almost definitely need to use. For example, committing, pushing, branching, merging. What's a merge versus a rebase? I don't know if I added cherry picking. I think I might have decided that let's not cover that. There's a lot of information about Git out there. There's a few great new books out there as well, including Head First Git and another book whose name I can't remember, but I'll try and give it to you so it can be in the show notes. A lot of great new resources on Git. But for the longest time, a lot of people were trying to teach Git from the command line in terms of teaching, like, here are all the features, pick and choose the ones you want, like cherry pick the things that you want. And I think what we really needed to have taught developers is like, here is your entry level Git. here is the kind of like level up. And then from there, this team uses Git in this way, and these are the things that you will use, and this is how you will use it. And I think that way we can get a bit less confused over what's rebase versus a merge, and when do I use these various features. I think that it just becomes very complicated to understand these things. However, I'm also a big fan of trunk-based development, and I'm not a big fan of long-lived branches. I don't like the idea of having a long-lived feature branch which needs merging or rebase, and rebasing a long-lived feature branch is like the most difficult thing that you can do. You need to do regular merging between various branches. I don't like the idea of having a branch of work which is, you might be running your tests on it, but you're not doing continuous integration, because continuous integration means integrating it, not just running your tests on it. So these are some of the other patterns that you can have in Git that I personally don't like, because I think it pushes a lot of the pain to the end of the development process, by which you get to the point, like Ixchel was saying, like by the time you start merging or rebasing or trying to actually integrate your work, you've forgotten what you were working on. The code base has moved on from where you started. You're not really sure how your changes are impacted by someone else's changes. And I have often seen people going, I don't know what this diff means. I'm just going to take my changes and trample all over someone else's, or I'll take all their changes and just rewrite the whole thing. And this is when we get back to manual processes and toil and pain. I think that some of these tools just can make it too easy to do things which make developers' lives difficult. But again, it's all about the people, it's all about the team, it's how the team chooses to work, and it's about having a consistent process across all the people in that one team and understanding how things are done, and also regularly integrating, in my personal opinion.
Very familiar things that you brought up there. So Pierre-Étienne, I was wondering, of course, I know you from the Pijul version control system, and I was wondering if the things that Trisha just told us also inspired you a bit to start working on that, long-lived feature branches and conflicts that are very hard to merge.
Literally every single sentence said by Ixchel and Trisha in the last 5 minutes were big triggers for me. I've had to take notes actually, so there's a lot for me to comment on. I'll try to be brief, but it will be hard. Well, Ixchel said something that I found really very relevant. She said that few developers are proficient in Git. So how is it even possible that a tool that's 18 years old, that's widely used by everybody in the world, is in the state where a few people are proficient in it? I'll actually elaborate on that and go a bit further. How is it possible that nobody outside our industry uses Git? It's supposed to be one of the great prides of computer developers that we've been able to build a tool that is this powerful and useful and relevant to all kinds of projects, well, except none in the actual world. So it's relevant to all projects, but it has to follow good practices. So good and bad practices were repeated many times by both Ixchel and Trisha. So yeah, good practices. So what's a good practice? Let's say I want to build something with my Lego set, for example. I love playing Lego, right? So I want to build like, let's say, a car in Lego. So what's a good practice for that? There's no real good practice. Like, look, we should just play and let the tools do what they're meant to do. Like, if I want to use a screwdriver on a screw, so what's a good practice for that? Well, just use it. So it's striking to me that we've not been able to export our technologies to outside our little tiny field. Like, well, computer science is not exactly a tiny field, but anyway. For example, these days, who doesn't use stuff that was invented at NASA, for example? Everybody uses NASA invented stuff, like from silverware to outdoor equipment to like anything really. Like, and NASA is really proud of it and communicates heavily with that. Who uses stuff not in computing that is invented at Git? Nobody. I think that's striking, and it's not because the tool is too young. The tool is like 18 years old, 500 different commands, like sub-commands. And that's something I think, I think Trisha said it's like there's lots and lots of commands, and nobody really uses it, like knows every single command. One link I've posted in this chat is the Git man page generator. It's a website that generates a new man page for Git randomly every time you click on it. The man pages are obviously completely fake, but they sound real. Like when you read them, you're like, oh yeah, this could definitely be a Git command. This is incredibly complicated. So yeah, what inspired us to start Pijul was that we needed a tool that would allow us to do everything Git can do, but also be simple and, simple to use, really fast. That was a requirement, and that would let people just work instead of teaching them how to, teaching them the good practices, telling them whether to merge, to rebase, to cherry pick. Well, all these 3 commands in Pijul are the same one. You just apply a patch. And that's actually what you want to do. When you're rebasing stuff, you're just using patch commutativity to swap the order, for example. So and that's the default in Pijul. It's the default because you don't need to swap the order. The order is irrelevant. If you can apply the patches in 2 different orders, you don't need to swap the order because it's the same. And that thing, even if you don't swap, if in Pijul, if you don't think you're using patch commutativity, you're still using it, you're still benefiting from it. So just some context here. So Pijul is a tool that's based entirely on patches instead of snapshots. So commits are snapshots, and Git rarely uses patches. And in Pijul, we do the opposite. We focus primarily on patches, and the user only sees patches. And then behind the like under the hood, we're using a giant data structure, a graph-like data structure that's used to merge all the patches. So the patches are not exactly Unix patches; they have a little bit more information. But we're using a data structure that's actually a CRDT. It wasn't found in this way. It was found by asking the question. It was a purely theoretical question. We want to handle changes on files, right? So what is this? So okay, we can have conflicts sometimes, and conflicts are bad, and nobody likes them, right? So what is the question? The initial question was, what is the minimal extension to files that can tolerate conflicts? What does it mean to tolerate conflicts? So asking this question means, what is, like, you can merge your changes, you can apply your patches all the time, always. Sometimes you will have conflicts, and because you've asked that question mathematically, you know that your data structure will model conflicts properly. So you can apply your patches, you will have conflicts, and at the end of the sequence of patches you've applied, you can ask the question, okay, where are my conflicts? And then you can solve them. You solve them by creating, guess what, a patch. And when you send that patch out to others who may have the same conflicts, well, it solves them for them too. So you don't have to worry about whether my branch is long-lived, short-lived, or a feature branch. You're just using branches and patches, and it's much simpler. You have way fewer concepts, and you can do the exact same things, well, except producing the bad merges in Git, which you can very easily get, even by following good practices. Yes, all these issues, the 2 of you have mentioned, were definitely a starting point for us.
Yeah, thanks, Pierre-Étienne. So, quick follow-up question here. I'm assuming you use Pijul yourself.
Yeah, I don't use any other version control system.
Yeah. I'm not surprised. You said you can either choose to use short-lived branches or long-lived branches with Pijul, that it would be just as easy. So, what is your preference there?
Well, it depends. I don't use branches too often, to be honest. My favorite model of branching is patches. The reason we use short-lived branches or feature branches or trunk-based development is that we want our different features to be independent from each other. And why do we want to do that? Because we want to be able to maybe push them independently from each other, or maybe undo them, right? And when you have a system that handles patches properly, this is something you can do even without branches. So, for example, in Pijul, let's say you have 2 different patches that introduce features, and Git you would call them branches, and it would require you to plan your work ahead of time to say, well, now I'm working on this feature. But that's not at all the way I work. Well, maybe it's not suited for everybody, because That's not at all the way I work. Usually when I start working on a feature, all things are broken always, and I discover a bug, which leads me to believe that I should be working on another feature instead. So that you like in Git, you would have to use all the arsenal of stashing and staging and whatnot, right? But in Pijul, you can just write patches. Well, this is the only command we have, so you're bound to use it anyway. So, so creating a patch, applying a patch. That's all we do. And so, my favorite model of branching is patches. So you're working on two features in parallel. Just make two patches, and then you'll be able to push them independently, and you'll be able to unrecord, undo them independently. If they're separable actually. So if they depend on each other, they touch the same place in the file, or then you will have to be a bit more rigorous and just meaning to just do it and then solve the conflicts afterwards if you want. Like to do the actual branches. We do have branches in Pijul, but you can also use patches predominantly. And so another model of branching, which I've also used sometimes, is you want to maintain two different versions in parallel. Like let's say, for example, the feature in the language you're using is not quite ready, but you want to still experiment with it. And all the bug fixes you find while experimenting with that, you want to backport them to your branch. So there you have two long-lived branches, and they're necessary for your users, for your customers, because your customers want to be able to, like two different classes of customers want two different versions. And then you'll be able to just backport. You won't have to backport, actually. You just have to take the bug fixes, take the bug fixing patches and just apply them to your previous branch. And that's it. And then when you merge everything later, because the patch, when you apply them, don't change their identity, you'll still be able to merge all the other changes, and you won't get any merge conflicts because the patches are the same. Like one single patch is the same no matter where it lives. It can be applied to different branches in different contexts. That won't change its identity. So you will still be able to merge the new experimental branch without losing your mind on conflict resolution and all that kind of stuff.
Trisha, you also mentioned trunk-based development, just as Pierre-Étienne did a few moments ago. One thing we could do is switch to Pijul. I'm all for it, but I still have to convince my coworkers and the client side that I'm working. But I think a few of the trunk-based development ideas can still be applied regardless of what version control system you're using, right?
I wrote a blog post on it a couple of weeks ago. When I worked with Dave Farley, who wrote the continuous delivery book, we were doing, well, to be fair, we were using Subversion, but even if we hadn't been using Subversion, we would have been using trunk-based development. The idea being that everyone is working against trunk. They don't have their own branches. They're not doing feature branches. The only branch you have is that the code that's on your machine is separate to the main trunk. And it works in Git as well. You make some changes, you make sure everything's compiling, you make sure all the tests are running, you commit it to trunk, to the main branch. And then that way, because your CI is working all the time on your trunk, you know that all your acceptance tests pass, all of your performance tests meet the demands, and your trunk is always ready for deployment as well, because this is an important thing for continuous deployment. The idea being that any point in time, you take what's on trunk, you know all the test paths, and you just deploy it whenever you want to. When I was working this way with Dave Farley, it was a few years ago, and we were doing like releases every few weeks. And I know nowadays lots of people are doing microservices and they're releasing potentially multiple times a day. But to me, that doesn't mean that you can't still do a development model where you are pushing your code into trunk all the time. If your feature's not ready, it should still be compiling, even if it takes you 2 weeks to create a feature, because, for example, I was working on a financial exchange, and some of these features take quite a long time to implement, new instruments or new ways of working with the account. But you can be using feature toggles or literally just code paths that can't be reached until you actually connect them up via a button on the UI or whatever it is. But all the time that you're working on this feature, even if it's a long-lived feature, you're still working on the main code base. You're still not merging the main code base into your code base. The only way you're merging it is when you do a get, a fetch. And you know that your code is always compiling. and you know that your code will continue to compile against trunk because you're constantly working against trunk. You're also getting all of the other developers' fixes and changes as they work against trunk too. Now, I did write a blog post about this recently. I understand there are, like with anything, there are lots of it depends and criticisms and places where it doesn't work. So, for example, if you've got 300 developers working on a huge application, which is all in one module on trunk, maybe you're going to end up with a lot of problems, and you're going to be triggering an awful lot of CI builds on the same branch or on the trunk. However, I think if you've got 300 developers working on one large mono repo, I think you've got other problems as well. I think the movement towards microservices came because now we have a lot of big code. We have, like I think Ixchel mentioned this as well. These code bases are getting bigger. You've got more developers working on code. One of the ways to address that is to split it up into separate services or separate modules, separate teams. So no, of course, something like trunk-based development doesn't necessarily scale if you've got 300 developers. But if you've got 300 developers, you have a scaling problem anyway, probably. So my preference is that the core of what you're working on, be it a microservice or a module or a project, all the developers who are working on that should be committing to that main trunk. The only real exception is something that Pierre-Étienne mentioned, which is that sometimes you might have the branch that's in production and the branch that's not in production. So I think that's the exception there.
So Trisha, what would be your advice for people who are currently in a feature-based approach but really want to transition to trunk-based development? And also, maybe a second question, maybe you can address it as well. What if the context you're working in on a platform level demands that you use feature branches because it's linked to ticketing system IDs or something? Could you give us some advice on that?
I've been thinking about this a bunch. And we have to bear in mind that I've been doing developer advocacy for the last 10 years or so. So maybe I'm a little bit divorced from the reality of real developers. Having said that, the flip side is I do quite a lot of open source development, which means that I often wander off for weeks at a time, don't do any code, and then come back to an open source project. And of course, it's moved on since I did some work. And one of the most important things in these environments is to continuously pull from what's new into your branches, into your fork. And I think this is one of the things that I have seen go wrong in long-lived feature branches, is that people start a feature branch, and I've worked in teams like this. You start a feature branch when you start that feature, and like you said, you've got a tracking number for the issue number or the bug or whatever, and you start working on it today and you finish it next Thursday. And during those 2 weeks, you haven't pulled from main at all. And that's when, and you haven't merged any of the other developers' stuff into your branch. And that's when you start getting like merge hell, because you merge it. You may hopefully merge it at some point before you do your pull request or your merge or your rebase. If you're regularly fetching from what's in trunk, then you end up having smaller lots of changes that you need to pull into your code. You have fewer chances of merge conflicts, and you're working on the most up-to-date code, which means that as soon as someone has worked on something which is going to conflict with yours, you see it sooner rather than later. So one thing is I would definitely pull more regularly from a trunk if you have to have long-lived feature branches. And the other thing is to try not to have long-lived feature branches. It's really important, and this is a computer science problem since forever. This is not a Git thing. It's important to think about things in much smaller pieces of work than we generally have been. Right? You shouldn't be working in isolation on one thing for 2 weeks. I mean, a lot of people were asking me after the blog post, what's a long-lived feature branch? Anything longer than 24 hours, really? Because you can't be working in isolation for that amount of time. You need to be able to split stuff up. If you're working on something super separate, it's kind of easier in a way. You created a new instrument class, let's say, for the particular instrument that you're creating. You can commit that and you merge it into main, and nobody's using it. So it doesn't really matter. There's no impact to that. So small changes, very small changes. And if there's no conflicts and nothing in the way, merge it back into trunk as soon as possible. If you can't merge it back into trunk for whatever reason, just continuously pull trunk back into your feature branch.
So Ixchel, you've heard Pierre-Étienne talk about his version control system for a few minutes. Did you hear some things where you thought about and thought, I would really like to have that in my version control setup? Or maybe you can talk about a few other improvements that you would like from your version control. system. You must have been thinking about this in the past years. I mean, I think every Git user has. I like Git, but it just needs to add this extra feature.
What Pierre-Étienne was mentioning, it's really interesting because the workflow that he described, it was very, very easy, like a communication between humans and saying like, this is what has changed. And because you don't have so many open context, then it's easier to keep track to what is actually the change. Because let's face it, as humans, we can only retain very small amount of things in our head, in our working memory. So going beyond that doesn't make sense. I mean, we can be working in 10 different features, but not at the same time. We can't. Like, that is not human possible. So at some point, it's what Trish is saying, like, you have to reduce it to the bare minimum, work on it, and serialize. Like, sadly, for all the synchronous that we like to talk, we are very serial, like humans. We focus on this and then on that. We can have different ideas during the day, and that can be totally asynchronous and in parallel. But working is something that we have to start and finish at some point. So the simplicity of our tools that allow us to actually focus on a specific thing makes total sense for me. Now, the other thing that brings a lot of problems into development is the human factor. And I put a link about conventional commits, because my whole point is, I'm not going to even talk about long-lived feature branches from, no, it's like, write down why you have introduced those changes. What? You have the freaking diff there. That's not a question. I can see what happened, but not why. Follow a pattern. I agree with your team. What makes more sense? The whole history of Git should give you a more enriching idea of what it was happening, what actually, maybe not what we were thinking and we didn't go in that direction, but at least hinting out like, this is why it actually happened. Not what actually happened, but why it happened. I think for tools that follow better the human interaction of how human works, it's going to reduce the overhead for us using it, and we will be more efficient using them. So that's why it totally makes sense for me. Please be kind to your fellow developer, because you may be the one that is going to go like, what were we thinking? Like, wait, were we thinking at this point?
I really want to follow up on that as well. The why, not what, on commit messages, particularly, again, coming back to IntelliJ IDEA, I quite often use the git annotate on the IDE. So when I'm looking at a line of code and I see, I don't know, some weird if statement, if I use annotate and it says, and it has the commit message there in the IDE, and it says, I was working on something which makes sure that users don't get screwed over by something, you're like, oh, right, now I know why this if statement exists. So now I know what this test is trying to do. Whereas if it says, added a test to make sure issue number 521 works, I'm like, that's not very helpful.
So all what you're saying is we should be talking about changes. And you're actually, when you're talking about commits, we're talking about changes, yet you're using a system that only stores snapshots. So Git is entirely about the what. A snapshot is an entire version of your project. So you're entirely about what is there. You're not talking about what changed since last time. In order to get that back in Git, you have to recompute it from two different commits, and you'll have an automated machine generated answer that might make sense, but sometimes doesn't. Like, I have examples of like giant Git failures. They're obviously not too common, but merges where Alice and Bob are working in parallel. Alice is working towards the beginning of the file, and Bob is working towards the end of the file. And when they merge, Bob's new changes, so at the end of the file, are inserted into Alice's new changes. And that's an issue in three-way merge, and there's just not enough information for these algorithms to work. So you could not possibly solve the merge problem that Git is trying to solve correctly in all cases. This is just to mean like, yeah, you're talking about what you want is changes and what everybody wants is changes. Nobody's ever seen a commit actually, except maybe Git developers. When you are trying to visualize a commit in any UI, you get presented with a change, and that's not what a commit is. And you've probably, since you've done advocacy for all these years, you've probably seen countless examples of junior or maybe not so junior devs saying, "What? No, that's impossible. The commit is a change." No, the commit is not a change. It's not a diff.
I think I already encountered some love for some of the features of Pijul with the other two guests that we have. And I think it would really fit well with this trunk-based development approach that we have been talking about. So Pierre-Étienne, I've been meaning to ask you, do you understand why so many people are still using Git currently? Can you think of a reason why they are?
I can think of many reasons. One thing I haven't stated since the beginning of this podcast is that I'm a big Git fan, actually. I also use the command line, and I also look at the ref log, and I love how it's just not meant to merge, because it was designed by people who don't like they have very strong opinions on how they collaborate with others, right? Linux kernel developers. It's a very exclusive team working in one very rigid way that is not suitable for all kinds of projects. It's also like the Linux kernel is its own thing, right? It's probably the farthest outlier in all software development projects that there is. And we're all taking their development tools and saying, well, if it fits the Linux kernel, it probably fits our project. But no, that's completely wrong. Yeah. So one thing is, it just works. Git really works, and it works well. It's very elegant. I used to say simple because I take that as compliments, but sometimes people say, look at they see simple and they're like, oh, simple is probably not a feature, but like actually being simple is actually a really strong feature. Designing simple systems that work is great. And saying Git is simple. Now I prefer to say elegant because it's less ambiguous, let's say. So yeah, Git is really elegant. Its data structures are really small, and they don't do much, right? They don't do their rebase as well. They don't do their merge as well. They are completely unable to cherry pick. Even though they try to mimic all these commands, they're unable to actually implement them fully, properly, rigorously. But it's a great tool. So it works. It actually works. Pijul is much more complicated. It's very simple to use, very easy to use, but it's also extremely complicated under the hood to implement to make it fast. Like, for example, I've had to write database backend, especially for people. So this was a nightmare to write. Like it's called Sanakirja, it means dictionary in Finnish. It's just a key value store, which turned out to be the fastest open source key value store there is. But it was also a nightmare to write. And the reason I needed to write it was not even performance. The reason was that I wanted to be able to fork a key value table. So when you have a dictionary, you want to be able to just fork it and get two separate copies without copying a single byte. So that's what Sanakirja does, using persistent data structures, garbage collection, reference counting, and so on. So, but this is a giant machine. It's really complicated. Like there's few lines of code, but it's not easy. That's one reason, but I doubt this is the main reason, because very few people know the internals of Git. I think one of the reasons is that, well, it works. People have nightmarish memoirs of switching to Git when they switched from SVN with all these little hacks that they were using, and they switched to Git. I know a trivia from some companies where people actually physically fought over this issue of switching to Git. Like during a meeting, two men, obviously, women wouldn't do that, I guess. So two men at some point said, well, let's settle it out just outside the building. So now they're looking at a new tool, be it Pijul or whatever, and they're like, no, we're not going through that again. So that's one of the issues. Another issue, and it's actually appeared in the chat, in our podcast chat here, the tools aren't quite ready yet. For example, for Git, we have GitHub, It hasn't innovated in any way in a number of years, but it works. There's 500 developers taking care of your source code. For people, we've had some. Well, like I wrote something called the Nest. I released it with the alpha version of Pijul back in November 2020, I guess. It's okay, but it went through a number of issues. Like for example, the OVH data center fire in March 2021. My server was in the fire, so I've had to rewrite a replication layer to be able to replicate it in 3 different data centers. So I did that, but the tools that this uses, like PostgreSQL, don't really work well because I wanted to do, like the main issue in summary was that I wanted to do a join, like a database join between information that's stored in Pijul repositories and information that's stored in PostgreSQL. So in PostgreSQL, you can easily do a join between 2 tables, but you cannot really do a join between 2 databases, especially if one of them is not even stored in Postgres, but it's stored in the form of Pijul repositories. So this doesn't work very well, and it causes the machines to go down sometimes. Not actually go down, but just be under too much load. And so this should be okay, but actually because of how PostgreSQL works, it just sometimes loses data. So that's really bad. Having downtime is okay, losing people's data is not. So I decided to rewrite it and released it recently, but we're currently going under a major rewrite and redesign of the ecosystem around like repository hosting. So, for example, just saying these things, this is probably very scary for lots of teams. So Pijul itself works very well, and you can use it readily in repositories. You're very unlikely to encounter bugs. We're testing it all the time on crazy scenarios and huge repositories and so on. So the tool itself is ready, but the tooling around it, like hosting services and so on, we're currently finding a better way to do it. It's probably just a matter of weeks or something, because it's the maturity of the ecosystem is not the same.
Yeah, because you mentioned a few possible reasons why people would still be using Git. So I wanted to ask you 2 small questions. The first one is it actually one of your goals to grow Pijul's market share? And secondly, if yes, what do you think would be needed to achieve that growth?
Well, the initial goal was that the problem was interesting. And that's how Florent Becker and myself started working. We didn't have any idea that it would result in a tool like that. Or like, Darks has huge performance problems. And Florent was very knowledgeable about Darks, because he was one of the maintainers. And so he told me, well, no one really knows why the merge can sometimes take exponential time. And we're like, actually, we're computer scientists working on that all the time on asynchronous computing models. So this is a job for us. Okay, let's do it. And so we looked at the bibliography and started noticing some cool algorithms that we could use, and we needed to expand on them and so on. So they started because the problem was interesting. But now, growing market share. I think our industry is quite conservative in that regard. It's hard to make people change. We like to see ourselves as the heroes of progress and modernity, but actually we're very, very conservative when it comes to our own methods. This will be growing people's market share in the current market of Git will be hard. But there's another market that's completely unreachable by Git. That's people not even doing code, legal documents, office documents. All these people, they desperately need version control, and they cannot possibly use tools like Git. Even if you restricted their files to formats we know how to handle with Git, like Markdown, LaTeX, and these things, even that would be really hard to use. Go teach a parliament member how to rebase and whether they should merge or rebase or cherry pick something from another law. This is completely impossible. So same thing for lawyers. Lawyers work at really fast paces, like much faster than us, and so they could they could not possibly spend half a day on dealing with two branches that have gone wild because one of the junior lawyers in the team decided to do a revert or whatnot. Right? Like these markets are definitely addressable by people, and there's another niche in our industry, which is video game developers. So these people don't see their needs addressed by anybody. Most teams are currently using Perforce, which is a SVN done like the SVN was CVS done right, and Perforce is SVN done wrong. So so yeah, most video game teams are still stuck with that.
Sorry, I really wanted to follow up on something you said there, which is absolutely fascinating to me. It's impossible to persuade a lawyer to spend half a day like fixing up a merge which has gone wrong. And this is something this comes back down to the DPE stuff that we're talking about at Gradle. As in the software industry, we're kind of fine for really expensive software engineers to spend half a day or a day mucking around with merges. And these are the sorts of things that get in the way of our productivity. And yet we kind of tolerate them. It's fine to spend $1,000 on the fact that the merge went wrong. And I think that we have become very tolerant of this kind of thing precisely because we don't want the pain of changing tools or migrating. And I get that too, because migration is an enormous mess. But we will tolerate small pains like half a day here and a day there on tools and processes which are not working for us. And I think that this, particularly in the development environment, in the production environment, we've got a lot better at circling back to where we started this conversation. We've got a lot better at automation, pipelines, smoothing things out. But when it comes to the development environment, we still tolerate this nonsense of expensive toil. And I think that's kind of crazy.
Yeah, I think lawyers would just laugh at us if they knew.
Yeah, it seems to me that Pijul could also really benefit then from plugins for popular IDEs or maybe graphical ways to show the state of your version control, because lawyers are not going to learn Pijul command line, I can imagine.
Absolutely, and it's very the Pijul model is very suitable for that. You can easily visualize patches, and patches is something everybody understands. And you can also have patches that are not necessarily on lines, but that can work on words, for example, or any unit. Actually, you can change the diff algorithm as you please.
Interesting. So, Ixchel, I wanted to ask you a question that is about 10 years into the future. Suppose we could fast forward 10 years into the future right now, and we would be able to compare that state of source control and build automation to the current state that we have right now. What do you think would be the biggest difference?
Certainly, as we have heard, even though we have, as Pierre mentioned, a very, very elegant tool right now, for the comment that we have said, this is really not the best suitable. Like 18 years, not all developers know how to use it to its full potential, which either points towards we are difficult to teach, or maybe the tool is not working. It's like when people say go against the grain, maybe this is a case. So in my point of view, there are so many things that we have learned from managing a large amount of information that changes in a strategic or in a specific way. Is this the best we can do? Certainly not. The numbers speak for themselves. The experience of the developers speak for themselves. So I know that it has to be a change. One of the changes that I have seen, but it's a totally different thing. It's you have your Git and you're building a lot of other tools on top of it. Bug tracking, CI/CD, documentation, etc., etc. So I have heard that, and I have seen that a lot of people, when they refer to the next set of tools, they refer to those. More things to do near the source code. But that doesn't mean that it's a different version control system. You see the difference. So I think both are going to evolve naturally. We will have to find a way to actually make it more interesting for developers to use efficiently, proficiently, and easy, something that is really important. I mean, we're talking about people collaborating in large code bases at the asynchronous times And we cannot only rely on best practices, because best practices are amazing, but it's not a rule. And we are not very good at not following rules. So the future, something different that I hope more developers and even non-developers can use without going into the merge hell that we have spoken at so many points during this conversation. I think a lot of other tools will live very, very close to source, because we have seen it. We need CI/CD, we need documentation, we need, even I think testing will, because it's so important, it will live in a different way. Right now, being part of the source code is super important. It's really important. But now we have more integrations, and suddenly you start seeing like developers don't know where to pull them or like to put them. For example, consumer integration test consumer from the producer perspective. You already have problems like locating it in some way. So I think it will actually live in its own close, but in a different way. That's what I hope. Something that works efficient for the computer, that computers can work with it in the most automatic way, but also developers can work in the human way too.
And Trisha, what do you think 10 years from now, the world of source control and build automation?
I think Ixchel's right. I hadn't even realized it was ripe for change until we had this conversation, but it's ripe for change. I think there's a number of things that we've talked about today which are really important. For example, we've seen that Git is very fully featured, simple-ish, like it's implemented in a simple way, but unfortunately exposes itself in a complicated way. So it means that developers have to know a whole bunch of different ways to work with it and then figure out their own human best practices to layer over the top. Or like Ixchel was saying, like maybe having tooling on top to make it simpler to work. I really like what Pierre-Étienne said about what if, you have something which is simple to work with and complicated underneath. I mean, that feels a little bit like Java, the programming language, right? From a programming language perspective, it hasn't evolved that much, but it's kind of simple to understand. But the JVM does a lot of hard work for you and you don't have to worry about it. That's why it's one of the fastest languages in the world. And you don't see that and you don't have to code for that. And that's where I would like to see our version control systems go. So you use it, it just works. And maybe it can evolve in the background without you having to worry about new commands, new ways to work with it, new best practices. So I think something which is a fundamental building block that we don't have to care about helps developer productivity, because you can automate that stuff and not worry about it. And then we can worry about the things we care about. I think layering on process and people stuff over the top of something to fix the holes in our tooling is not sustainable. It's not scalable. We can't keep patching around these problems by having, for example, code reviews and pull requests. I've seen a lot of complaints about how, what if you have a process that doesn't have code reviews or pull requests? How will you be able to function as a team? Well, what if we have things like pair programming, which I prefer? Or what if we actually invested in our juniors so we could rely on them to write code instead of assuming they write terrible code and having to do tedious code reviews at the end of it? These kinds of things. What I really liked about what Pierre-Étienne said as well is like this idea of as developers in particular, we like to solve problems. So we see a problem and we solve it by perhaps layering something over the top of it. But what if we could step back and go, what if we can eliminate this problem? What if this problem is a side effect of, what if it's a smell of an incorrect tool, of something which can now be fixed by a different way forward? So I think that papering over these problems with processes or extra tooling, it might be better to sort of step back and figure out actually what should we be doing instead. The other thing I wanted to say is we haven't mentioned AI at all during this conversation, right? And in 10 years' time, I think AI is going to be a much larger part of the developer tool set. I don't know what it looks like yet. I don't think it's pairing with ChatGPT, but who knows? I want to kind of circle back to this idea of let's not use AI to paper over problems, for example. Let's not just use it to go, well, maybe AI can do our code reviews, maybe AI can do our merges. Okay, but what if we didn't need to do those things? What if there was a better, faster, easier, cleaner way? So we didn't have to keep layering on more tools and more technologies. So I think that's the only thing I really want to say about AI. I think it will probably contribute to this space. I would like us to not just add it as an extra piece of noise for us to debug later on down the line.
Trisha, I was so looking forward to talking with you for a morning without having to mention AI once. No, I don't blame you at all. Of course, that's a major influence, and and I tend to agree with you. Pierre-Étienne, you have the privilege to utter the final words of our conversation. What do you think of the world of build automation and source control in 10 years? Anything you would like to add?
Lots of things and nothing at the same time. As Yogi Berra said, predictions are hard, especially about the future. In this case, I think we've seen a dramatic acceleration in the change, in the pace of change that like in technologies were used. For example, if you think about not 10 years from now, but 10 years ago, Docker was just beginning. There was no Go. Scala was starting, like we were talking with Java developers here. So Scala was a thing, but not as widely used as today. There was no, like MixOS was absolutely unusable. And there was no, Angular, React in the JavaScript world. There was no, like Web 2.0 was a thing, but not actually a thing. So, and we didn't have TensorFlow, for example, for machine learning. If you look at all these, and I'm probably forgetting lots of stuff, right? If you look at all, Rust was not, it was a prototype from Mozilla aiming at like slightly better C++. Yeah, predictions, like things have been accelerating dramatically in the last 10 to 5 years, and so I don't know what the future will hold. It's really hard to tell. If I were to give us like a tiny prediction about version control, only because it's a topic I know quite a bit. Yeah, I think people will probably maybe some teams will switch to something like Pijul, or maybe not Pijul itself, but maybe like the workflows we're allowing people to do. I think this will be used elsewhere. We're already seeing the influence of the things we've been doing in other products, like even at GitHub and GitLab. Like people are using like the experimental things we've allowed ourselves to do. They've been used in other products. Like for example, if you look at comment signing by default in GitHub, that's something that we did first, and discussions instead of pull requests. So Pijul has a merger between discussions, like in the nest, we're using a completely different model from pull request. We're using just discussions, and you can attach patches to discussions. They're not pull requests or merge requests. They're just you can start discussing on the topic and then push a patch and say, well, I actually have a solution to that. Like push a patch to the discussion. Then you can review the patch independent of its context and just apply it as you want to your main branch on your computer, because you can always undo it. You can apply it to different contexts, so that you can test it like that. So we're already seeing the influence of the stuff we've done in other products. GitHub has introduced discussions, signed commits by default. This kind of thing. So yeah, I don't know what the future will hold. We'll see.
That's always the best answer, I think. We can all agree that it's a very interesting field that is changing rapidly, and I'm planning to be there every step of the way because I really like where the field is heading. I had a lot of fun. Thanks. Special thanks to our guests, Trisha, Ixchel, and Pierre-Étienne, for sharing your thoughts on version control and build automation. And of course, we want to thank you for listening to this podcast. Keep an eye on Foojay for future articles about development and everything related to the Java world. Thank you, and until next time.
Give me a foo, give me a J, give me the friends of OpenJDK.